So, in the first activity, we will be conducting a volcano experiment. The materials needed are calamansi, knife, containers or plastic cups, baking soda, and food coloring. So, to start our experiment, we have to cut our calamansi into half. Squeeze the sliced calamansi and quickly pour it into your plastic cups. The amount of the calamansi extracted may vary. Next is add a few drops of food coloring. We choose the red color, and lastly, place the baking powder and watch as the citric acid in the lemon juice reacts with the sodium bicarbonate in the baking powder. The reaction produces carbon dioxide gas, which creates bubbles and foams. So, this experiment involves an acid-base reaction. When calamansi juice or citric acid is mixed with baking powder, which contains sodium bicarbonate, an reaction occurs. The carbon dioxide gas produces and creates bubbles and foams that stimulates an eruption. The food coloring helps visualize this eruption. The chemical change is because a new substance, or the sodium citrate, water, and carbon dioxide are formed, and the reaction involves breaking and forming of chemical bonds.
So the next experiment that we're going to have is the experiment about food coloring in water versus salt water. The materials needed are 2 cups or any container, water, salt, and food coloring. The first step is to prepare the 2 plastic cups. Then pour water to the 2 plastic cups. After pouring water, put some amount of salt to the 1 cup. After putting some salt, stir well the water so the salt will dissolve to the water. Next is to put the food coloring to the cup with pure water. As you can see, the color blends well to the water. In the plain water, the food coloring dissolves quickly and uniformly. Next is put the food coloring in the plastic cup with salt. In the salt water, the food coloring may not dissolve as readily and can form streaks or clumps. The difference in behavior can be attributed to the density and ionic composition of the salt water compared to plain water. Salt water has a higher density, and the dissolved ions can interfere with the diffusion process of the food coloring molecules. This can slow down or prevent the food coloring from dispersing uniformly. So, those are our experiments for the first activity.
So we have the activity 2, which is the intensive versus extensive properties. First is the intensive property. We have here the silver spoon. The intensive property of silver spoon is its color. A silver spoon has a characteristic of shiny, metallic color that is intrinsic to silver. This property remains constant regardless of the size or shape of the spoon. The color can be observed visually by looking at the spoon under normal lighting conditions. So these properties can be observed and identified in real life because it is shiny metallic color of a silver spoon can be identified by observing it under light. This property helps distinguish it from spoons made of other materials like stainless steel or plastic. Next, we have the ceramic mug. So the intensive property of ceramic mug is its heat resistance. A ceramic mug has high heat resistance, an intrinsic property of the ceramic material. This property remains constant regardless of the size or shape of the mug. Heat resistance can be observed by pouring hot liquid such as boiling water or coffee into the mug and noting that the mug does not deform or get damaged. These properties can be observed and identified in real life. With the heat resistance, it can be identified by pouring hot beverages into the mug and noticing that it does not crack or get overly hot to the touch, demonstrating its ability to withstand high temperatures.
The next one is extensive property, which we have here water in a bottle. Extensive property volume. The volume of water in a bottle depends on the amount of water present. It can vary with the quality of water. Volume can be measured by using a measuring cup or graduated cylinder to determine the amount of water in the liters or millimeters. These properties can be observed and identified in real life by measuring the volume. Pour the water from the bottle into the graduate cylinder and read the measurement at eye level to get an accurate reading in millimeters or liters. Then the next is the bottle of shampoo. Extensive property volume. The volume of shampoo in a bottle is an extensive property because it depends on the amount of shampoo present. It can vary with the quantity. The volume can be measured by observing the markings on the side of the bottle or by pouring the shampoo into the measuring cup to determine the amount in millimeters or liters. These properties can be observed and identified in real life. With a volume, it can be measured by checking the label or the bottle for the amount of shampoo it contains or by pouring into a measuring cup. This helps in determining how much product is left and when the purchase more.
So that's all with the activity 2.